All right, so today we're going to talk more about simplifying. Tomorrow we're going to get into solving. Friday will be more solving. Formative next week, Tuesday on simplifying and solving. And then we'll get into proving identities. That'll take all of next week. And then we're going to test on this stuff on the 6th of February. So that's 2 weeks from yesterday. Okay? So, a couple of warm-up problems here for you off the start. You will need to have your own notes out. You will need to have your purple sheet out. Okay? So notes and purple sheet.
I could stand up for a second.
So cosine is cosine. Sine or tangent is sine over cosine. So those cosines cancel out, and we just are left with sine of x. For the first one. Secant is 1 over cosine. Cotangent is cosine over sine. The cosines cancel out, leaving me with 1 over sine, which is cosecant. Agree with both of those?
Yes, sir.
Yeah. Okay. All right. I don't think there's anything more on the warm-up. I should know it by now. Okay. So let's get into it now. Okay. So if I'm going to add fractions, let's go all the way back to elementary school. Okay. Adding fractions. What do I first have to find? Common denominator. What after I find the common denominators, what do I have to do?
Do the operation.
So I gotta adjust the fractions first,
Yeah.
right? Because I gotta make the fractions fit the common denominator. Okay. Then add or subtract on the top, right? What about the denominator? Stays the same. And then what? Last. Simplify if we can. Okay? Right? So those 4 steps, if we were adding 1/2 and 1/3, 17/14 and 8/15, okay, subtracting those 2, same steps. Even if we've got trig function, same steps. First step is you got to find yourself a common denominator. What is the common denominator between these 2 fractions? And 1 minus sine of x. Yep, they're not the same, so we got to have each of them. Okay. That was step 1. We found our common denominator. Step 2 said now we got to adjust our fraction. What's missing in the first one? 1 minus sine of x. What's missing in the second one? Step 3 said, now we can add or subtract our tops. 1 minus sine of x plus 1 plus sine of x. The bottom stays sine squared x or sine x squared? Sine squared x. Yeah, we'll get there. Okay. Step 4 said now we got to simplify, right? What does the top simplify to be? 2. What does the bottom simplify to be? minus which one? Did you see it?
Square.
Sine squared x. It's different because you put the squared on the x, not on the sine, which is different. You know what I'm saying?
I suppose.
No, not supposed. It is. Does everybody understand how we got, or how Sadie got 1 minus sine squared x on the bottom? Just did the multiplication, double distributed, got it through. Okay. Anything else be simplified? What can the bottom become? Cosine squared of x. So in the end, we can write this as 2 secant squared. Good assist on that one.
I see it.
Okay? You now try secant squared over tangent minus tangent. Common denominator is tangent. First one didn't have to change. Second one changes to tangent squared of x. Combine the tops. Bottom stays the same. If you had me yesterday, I told you that anytime that you see a squared on one of the trig functions, it's probably on the purple sheet. So do you want to change around secant squared or do you want to change around tangent squared? Secant, okay, because it's number 11, right, on our sheet. Secant squared on our sheet is tangent squared plus 1. Tangent squared plus 1 minus tangent squared is just 1. And 1 over tangent is cotangent. And the sad thing is you gotta show all of that. Alright? You try that. Cosine is cosine. So we're there. Sorry, my OCD is kicking in. Now we can get a common denominator. Now we can add the numerators. my first class today got to right here, and they said, Lynn, do we have to show this current step that you are writing right now? And my answer to that is yes. Because that's the taking two fractions and combining it into one fraction. Very. So yes, you've got to show that step. Cosine squared plus sine squared then is 1. This is 1 over cosine, and 1 over cosine is secant. Okay. Good stuff. Good stuff. Okay. So complementary angles are two angles that add up to be 90 degrees. You've probably seen it from middle school and geometry and all that fun stuff. They add up to be 90 degrees. Algebraically, can we represent that if they are in degrees? So I'm going to give you the angle. So there's the angle, x degrees. What would the complement to that angle be? 90 minus x, then degrees. Okay. We deal in radians. So what if we measured our angles in radians? Again, I'm going to say the angle is now x radians. What would the complement then be? Hold on. Pi over 2 minus x? Pi over 2 minus x. And that would be in radians. Okay? What I'd like you to do now is if you have a calculator, I would like you to, let's start utilizing it. If you just have your phone, remember if you tip your phone to the side for this, I'm okay with it, and you get a scientific calculator. Okay? You don't have to do them all, but I'd like you to find me the values of those 6 things. If you're doing them, go do them in pairs. Okay? So find me the sine of 20 degrees, find me the cosine of 70 degrees, and compare those two. If you and a shoulder buddy, if you want to do one and your buddy does the other, and then you show each other the calculator, that works too. Okay? Sine of 42, cosine of 48, sine of 68, cosine of 22. Find me all of those, please.
I know I was born in the summer, but it's just not.
Is that you?
No, it's too warm.
Gotcha. So both of these should have been 0.3420. Both of these should be 0.6691, and both of these should be 0.9272. Yes? They should all be the same in the columns. Yes? Okay? Now, what can you tell me about the angles that those are from those pairs? They're complementary. So the sine of an angle is equal to the cosine of its complement, and vice versa. Okay? What that does is that gives us these next ones. These are formulas or identities number 12 through 17 on your purple sheet, which is basically the middle column on your purple sheet. Okay? What this column is saying is it's saying that the sine of an angle is equal to the cosine of its complement, and vice versa. The tangent of an angle is equal to the cotangent of its complement, and the secant of an angle is equal to the cosecant of its complement. And all vice versa. Okay? So let's try working with some of these identities now. So here is our first one. Sine of negative x times secant of pi over 2 minus x. First one, sine of negative x. On our purple sheet, not on our purple sheet. If so, give me a number. Negative sine of x, what's the number?
I don't know.
It's 2. Number 2. Okay? So that is negative sine of x. Okay? Secant pi over 2 minus of secant of pi over 2 minus x. That is formula number 17, and that tells us that that one is equal to cosecant of x, right? Well, the cosecant of x is 1 over the sine of x times negative sine of x. So it's just negative 1. Okay? You try that one. So sine is sine. Tangent is sine over cosine. Then that's going to be multiplied by cosine. So that's just going to be sine. Cosine of pi over 2 minus theta is going to be sine of theta. Sine of theta minus sine of theta is 0, plus sine of theta is sine of theta. Okay? Now, the only way that you get better at this stuff is by doing this stuff. So you have a blue packet that has multiple sheets in it. Right now, for the next half hour-ish, you have time to work on the front and the back side of those of that packet, of that first page in that packet. That should be done by in a half hour. Honestly, you should be done in 10, 15 minutes if you know what you're doing.
Wait, just the front and back.
Just the front and back of the first one. Because the second one, then now we're getting into solving, which is tomorrow. Yep, so just worksheet A and worksheet B.